Yep, schedule's done.
Okay, so we're gonna go ahead and get started, because why not? I'm gonna power through this.
Yeah.
Oh, all right. So this is a talk about converting 3D models into ceramic pottery. So my favorite tool to use, not the only tool I've used, but my favorite tool to use is OpenSCAD. What I'm going to do is I'm going to break this talk into 5 10-minute segments, and we're already late on the first segment. So some of you know about OpenSCAD. Those of you who don't know about OpenSCAD, this is going to be a real quick intro. OpenSCAD stands for Open Solid CAD. It's basically a way of doing computer-aided drafting programmatically rather than going through and clicking and building your models up using a mouse interface. This lets you do like basically put it, I'm going to say basically a lot because I'm starting to get nervous.
You're doing great, honey.
It's fine.
Stop the wedding.
Right.
Bless your
So it's free and open source, which I like, except when it screws up. And it's VRML-esque, which I also like because I learned VRML as my second language. And it's more like coding than drawing, which is that's different than, say, Solid CAD, if you're familiar with Solid CAD. Or AutoCAD or one of those things where you have to have a mouse and you're noodling around, pulling and pushing and adding stuff through the mouse. So this is kind of the exercise segment of this, where I'm going to actually stop the thing and go in and walk through the process. So, Solid CAD. One of the neat things about OpenSCAD is that you can really quickly define stuff. So, what this is doing is this is saying, build me a cube that is 1 by 1 by 1. In every CAD tool, and then we get to zoom in because I had zoomed out. In every CAD tool, or most CAD tools, don't have a concept of a unit. They basically say you define in your post-processing what 1 stands for, what 1 means. So what we do, because we're doing 3D printing, is 1 is a millimeter. So the unit 1 is a millimeter. Because we're American, we oftentimes can't think in millimeters, and so it's very easy to do something like this, where you just define a variable, and then you can say, now give me a sphere with a radius of 1 inch. And then we zoom out, and now I have that sphere. You can also do neat things like $FN. This is the divisions that it's going to split it by. So you see how it curls up. You can change it to 180, and that'll actually translate over when you're doing your 3D printing as well. So if you want it to be real chunky, then you can do something like this, and that'll actually translate over, and you'll get chunky blocks. There's also the concept of what do you call it? Combining shapes together. So if I want, I can change this to be 5 times inch to millimeter. And then,
And since you didn't specify a different origin point, does that mean that the original cube is now internal to the sphere?
yes, it's actually floating inside this sphere. And what I'm about to do is make it a little bit bigger so that it can be seen. So now we have a 5-inch by half inch by 1 inch rectangular prism that's kind of merging with this sphere here. Now what I can do is I can then say this is all one part with a union command, and what this does is this lets me, when I go back and drill holes, you're not going to see anything when I compile this, but when I go back and drill holes with this, it'll drill through both of these objects together, rather than if I were to drill through one and then another, and then the other. Drilling holes through objects is performed with a difference function. So I'm just going to change that so it isn't quite as nasty. And then what you can do is say CYLIND cylinder. And so you can either specify, as with the sphere, I specified a radius. You can also specify a D for diameter, and that'll change things. Likewise with the cylinder, D equals 1 inch, and then you can specify a height of. Actually, that might be too big, but we'll see. And yeah, that's what it was. Good save. So one of the neat things about this is you can comment out the difference here, and it should. Oh, now my computer's just compiling. All right. Huh? Yeah. I'm not sure. Oh, there we go. It was just taking a really long time. Okay, so I think my computer is behind a couple of compiles. So, there we go.
That's the real issue.
Say again?
So that's the real issue.
What?
Graphic.
Yeah, it's doing something funny with the graphics.
Do it forward.
Yeah. This is what happens when you do it live. Say again?
Dangerous difference.
Well, that's okay. I'm wrapping. Okay. So here we go. So what this did was this drilled that cylinder out of both the rectangular prism and the sphere. You see that? If I had not made a union of it, it would have drilled out of one or the other. And the way difference works is it will drill, it will remove, it'll do a binary difference from the every object defined in the block after the first block. So this union was necessary in order not to have the rectangular prism have a sphere cut out of it and then a cylinder cut out of it, you see. So you can also do, I'm going to show you one more thing that's fun, and then we're going to go on to more pottery related stuff. I'm going to swap this with a hole. And you can see it actually drug the, it basically did a shrink wrap around the sphere and the rectangle.
The rectangle had been off center.
Yes.
Notice it's not off center.
It is. It's just kind of harder to
Yeah.
see because the you can kind of see it from this angle.
I see.
But yeah, so hole is a fun thing. You can use that to combine, like basically combine disparate things together. One thing that I've used it to do was make prisms. So if you want to form right angles, you basically draw a very, very thin or zero-dimensional rectangle on one axis, and then the same on another axis, and then hold them together, and then that'll form a prism. You could also rotate them, and then that allows you to change the angle of the prism. So, fun things. So, going back to the slides. Maybe. All right. Mincast, so that, I covered some of this stuff in here. One of the, let's see, 3D printing positives. Oh, so once you've designed a thing that you want to print out and reproduce as pottery, one of the things that you have to consider is this thing going to be too complicated for me to get out of the plaster once I've cast it around it? And so that's definitely a thing that you should pay attention to. Like I say here, the more complicated the shape, the more complicated the mold. This is a bowl. It's a very, very straightforward shape. I basically took something like this, set it down, and then cast around it. And then when the plaster had cured, I just pulled the original thing out, and I was good. This is a one-piece mold. This is a three-piece mold. The reason it's 3 pieces is because there's a concave part underneath here that I wanted to capture, and so that meant that I couldn't just have a 2-part mold where it pulls apart without tearing the structure of the piece that was coming out. So you can see on this one, it actually does that. So you see here, there's actually 3 parts. So that's another thing. Another thing to think about when you're 3D printing a mold is ceramic shrinks when you fire it. Ceramic shrink, and depending on how you mix your slip, ceramic will shrink in the mold when as it's drying. So you can kind of see the original versus the finished product. That's a pretty significant shrinkage. That can is actually slightly larger than a regular soda can, and I had designed that on purpose because I wanted to be able to fit ice and a shot of Jack in that. So, so that is slightly like that'll hold a can of soda, and then it'll also hold a little bit more. But I had to scale it up by quite a significant amount. So that's an example of what can happen if you leave your 3D print to fate. So another thing to consider when you're doing your 3D prints is plaster will stick to PLA very, very, very well. And so what we do is we dip the positive into wax because plaster won't stick to wax. So when you're printing this thing, keep in mind that if you have really thin walls or really delicate parts, you're dipping this in wax, and it's a thermoplastic. It's hot. It can and will warp your stuff if you let it. So with this one, I actually didn't print a solid thing. I wanted the bowl to look like a bowl, and so I just made it so that the wall was 3 millimeters thick when I printed it. Here's a picture of me making a horrible, horrible mistake. I designed a cup that I wanted to cast, and then I was like, all right, I'm going to try a different thing, and I used the spiralize function on my 3D printer, and so it was exactly 1 filament's width thick, and so as soon as it went into the pot of wet wax, or melted wax, it immediately turned into gel, and like I had to print it as something. I had to reprint this one because it just completely fell apart in the wax, and then I had to fish it out of the wax. So that was fun. Now we're okay. I'm on schedule. Now we're going to talk about the actual casting, the plaster. What makes a good flask? So the flask is what holds the plaster around the positive. This is you're going to want something. I've made wood. I've made flasks out of wood. I've made flasks out of as you see here. This was a gallon bowl from Kroger. I just cut the top off of it. You don't see that. I see that. So this is what I'm talking about. So this was this mold right here before it actually got cast. One of the things that you need to think about is how much plaster you're mixing. So what you can do is you can get out a tape measure and measure it. You also, if your piece is hollow, then what you can do is real easily measure the volume of the thing that you're casting, and then scoop out the volume of the material, or of the positive, or you can take it and dip it in and measure the displacement from that. You generally want to know what volume of plaster that you need. Then what you do is you mix 3 pounds of pottery plaster for every quart of volume that you're going to be measuring, or that you're going to be pouring. And then say 3 pounds of USG #1 pottery plaster.
Wow.
I did that for Tyler, just to hurt him. So you've seen this slide. Basically, this is the bowl mold that I made here. We actually did 2 of them. This was the other part. I just took gallon bowls. This was that very sad cup. This was the second printing of that cup, where I dipped it in a lot faster, and so the wax didn't melt it to pieces. It's still not a good idea to use the spiralize for that. Another thing to think about is, so this is full of air, and you're about to pour something that's much heavier than air in on top of it. So you want to secure it to the base somehow in such a way that it will not, immediately separate and bubble up. That was another thing that has happened to me in the past was, I had to fish the thing out, pour the plaster back off, and then reattach it before the plaster set. It was kind of a panicky process. That didn't happen this time around, but that's happened before. Generally speaking, it's nice to. This is the plaster and the water that I was mixing. Generally speaking, you want to use clay to attach things when you're making molds, because clay does not stick to plaster. That sounds counterintuitive because you're saying, well, I'm using this plaster to make make something that is out of clay. So I would expect it to stick. Well, that's what the way the plaster works is it's pulling the water out, and when clay gets its water pulled out, it tends to shrink up and separate. So that works for us when we're doing mold making, and it also is the mechanism that we use to do the actual slip casting. So if you're using wood, then you're going to want to take some just regular throwing clay and seal up the cracks in that in the corners, and you're going to want to use clay to attach the positive to the plate, as you can see in one of these slides. Yeah, here we are. So that's regular wet throwing clay. Let's see. Plaster really likes to escape. It being a water-based thing, it's almost an oobleck as you're mixing it. It's a very fun thing to play with. But if you don't get all the nooks and crannies sealed with clay, then it will escape out of those nooks and crannies. And because it's heavier than water, it is more beloved of gravity, and so it will push more than you would expect if you're just calculating with gravity. So what we did was we basically just weighed it down with some heavy things in order to do that. Oh, here's a picture of where I didn't do that, and it actually did escape. So the neat thing about plaster is that if it escapes and you catch it, then you can basically just push the clay back over it, sealing the breach, and then scoop it into a bucket and then just pour it back in on top, and it'll be all right. So things to think about when you're making multi-part molds. Those pictures were just of a single part mold. Things is if you're casting in a flask, what you're doing is you have this in a box, right? And it's covered up with clay, and you're pouring plaster in on top of it. Well, what am I doing?
Filming you doing that.
Okay, so you're pouring plaster in on top, and then once it's set, you flip the thing over, pull the clay off, and then pour the next layer. And so that's how these two happen. In the case of the 3-part mold, there was another plug of clay on the bottom that I pulled off and then cast that part.
Do you have to put a layer of clay between the top of the lower part of the plaster so the two sections of plaster won't?
You do want to do something to prevent the two pieces from sticking together, because plaster loves to stick to plaster. What I use is saddle soap. You just spritz saddle soap. I'm gonna hop back on. Okay, sorry. You spritz saddle soap on it. That'll keep it from blocking. I've also used baby shampoo. That works just fine too.
I know for some complex shapes, you have to have screws, extra holes, so the air to go out through both clay's coming in here, the air going out the other hole.
Yeah, for some really complicated shapes, you do have to do some extraordinary things. I've not done anything like that, but the thing that you would want to be sure of when you're casting something like that as well is that you degas the slip before you pour it too, because plaster will seal up. It's self-sealing. I mean, if you look at this, there's all kinds of cracks in this, but when you pour slip into it, it'll leak a little bit and then it immediately seals itself, because the plaster just operates that fast on the water in the slip, and so it forms its own seal around around any holes. So if you had sprue holes like you're talking about, you would not want them to be small, because they would just be immediately covered up, and any kind of air bubbles in the slip that would prevent that would stop that process from happening real fast. Go ahead.
Are you degassable?
The same way you degas like silicone. You can use what do you call it? A vacuum, or you can put a vibrator on it and kind of shake it to get the bubbles to come in. But it's just as entertaining with silicone because you're on a time limit. Yeah.
So if you want to go, old school, I was thinking about cake mixes.
Mhm.
You can take a plastic bowl and just kind of drop it, and you just
Yeah.
and it'll shake it out, so you don't. When you're just getting started, you don't have a lot of money.
Mhm.
There you
Yeah.
go, 1940s.
What I do is I actually have a little vibrating sander that I pulled the sanding pads
that's
off
brilliant.
of, and then I just push it onto the bowl that I'm mixing the plaster in. And I mean, $15 from Harbor Freight. Let's see. So the thing to remember for this is there was a plug of clay that came up as well that never got removed, because I want to be able. I don't want to seal this thing completely in clay or in plaster, because I'm pouring into this and then I'm pouring the excess out of this, because I am forming a cavity. So, okay, I kind of covered some of this stuff. You can use Vaseline for keeping the two parts separate, but be super careful with the Vaseline, because it'll seal the plaster, and then the plaster is working on the clay by being porous and pulling water into itself. And so, even if it's around the edges, you're expecting the plaster to pull water out of the clay, like around the edges. So it's better to use soap. It's better, like saddle soap or baby shampoo, than I've used Vaseline before. It's like it can be problematic. After you've cast the mold, once it sets, not necessarily right away, but once it starts heating up, you like for simple molds, you can just pull the positive out of it right then, and then put it in the dehydrator. You can use a warm oven. Let's see. There we go. So this was that cup after it had been like cast. We basically took it over to a table saw and ran it through because it was sticking to the edges. And there it is. This is the dehydrator that I use. It's a Walmart dehydrator. We basically put a trash can on top of it, and it forces air, like warm air, through the thing being dehydrated, and so it works really, really well because there's a lot of moisture that has to be removed from plaster after it's immediately after it's been cast. So that is kind of useful to have. We're going to move along to the slip casting part of this. So once you have a mold, how do you use it? So this is so basically, what is slip? Ceramic slip is regular clay that has been chopped up really fine and soaked in water, and it's in suspension. So there's two ways of doing it. The way I started doing it was I was throwing things on the wheel, and I'm lousy at wheel throwing, but I enjoy it, so I'm making lots of messes. Like the first noun I throw on the wheel every time I sit down at the wheel is garbage. I know this, and so I'm immediately, as soon as I'm done with it, I throw it in the slip bucket, in the scrap bucket. So then, once my muscle memory gets back up, and the second thing is slightly less garbage, and the third thing is better than that. But you still wind up with lots and lots of excess. This is stuff that you're not going to be able to use again until you do something to it. You have to process the clay after it's been on the wheel. So the thing that I was doing was I was just adding extra water to it and then grinding it with a paint mixer and making slip with it, and then using it with slip molds. So you get to recycle. I'm a big proponent of conservation of money. So so basically, when I was first making slip this way, I wasn't using a deflocculant, and so in order to get the clay to be, to pour it all, I was having to use a lot of water. Otherwise, it would just stay chunky, and so that's why you see this versus this. It actually shrinks about 10% inside the mold, and then the rest of the shrinkage is during the various firings. So that's kind of one thing to think about when you're doing the slip casting, or when you're deciding what size mold or positive to make is. Am I going to be using a slip that has a deflocculant in it, i.e. I bought this slip online, or I went and did the research and mixed it myself, or am I is this just scraps? So if it's just scraps, then you want to size it up a little bit more, maybe add an extra 5% to the size to account for that. Or if it's not, then go ahead and set the mold to about just 10%, because that'll account for the shrinkage in the firings. I actually have a recipe on here for doing other slip casting. This takes a little bit of planning, because when you buy clay at say, what do you call it? Michael's, then, you know, they sell wet clay. And so you can either throw it on a wheel and then you know, let your scraps dry out, or you can chop them up and then let the pieces dry out. So, you know, that's that. One thing to think about is if you are soaking wet clay in water, wet clay actually is kind of hydrophobic. It's not like, it will absorb water, but you have to work it in order to get it to absorb water. Whereas dry clay is loves water. It will soak it right up, and it will soak it up to an excessive amount. So if you dropped a couple of cubes of clay that you had dried out, it will immediately pull up all the water, and now you're dealing more with slip than you are with you know, basically if you drop wet clay in, now you're having to go through and kind of break it up in your hand and kind of smoosh it around until it dissolves in the water. So in slip casting, the point is the plaster is absorbing water out of the slip, forming a skin of much denser clay on the edge, on the sides of the mold. So how long do I leave the slip in order to form the thickness of the vessel that I want is dependent on these various variables, or of these variables. So, you know, if I have a amateur slip that I just mixed up from castings, then it's gonna take a lot longer for the skin, like the walls of the pottery piece to build up, and the volume is going to drop. So one of the things that I got used to doing was I would pour the slip into the mold and then come back every 5-10 minutes or so and top it off, because it's pulling that much water out of the suspension. So this is a picture of, or a couple of pictures of the slip in these molds that we cast. Here you can kind of see the skin starting to form. You can kind of see the meniscus. Say again?
I was hoping.
What was the word you said?
Not meniscus.
Okay. Here's I kind of topped it off and kind of wanted to make it more obvious that there were a couple of layers of slip making up the skin. Then basically, once you have the thickness of the material, or of the vessel that you want, you dump it back out. So it's pretty straightforward. That's like there's no magic formula for slip casting. You basically just wait for the wall thickness. Well, I should say the magic is getting to know your slip and getting to know your mold. So once you know kind of what you're looking for, you can't really very easily measure without poking a hole in the wall of the slip in order to kind of gauge how thick it is when it's at this stage. You're basically saying.
Once you've poured out the excess slip, how much longer does it have to dry before you can remove the plastic mold?
That is also dependent on the type of slip you're using. The stuff I was using here
was professional grade slip. It had a deflocculant in it, so it was much, much denser. So there was not as much water, and so it wound up working, the mold wound up working a lot less. It didn't have to pull out as much water in order to build this stuff up. And so we actually were able to demold the ceramic pieces, or the greenware pieces, like maybe an hour or so after the casting. I mean, it happens pretty fast. Now that said, the amateur stuff that I was using, it was a day or more before we could safely remove that stuff. It took it a while.
Yeah, I took a ceramics class in college, but it was all throwing on the wheel. We didn't do any slip casting.
Yeah. Well, I enjoy them both. They're pretty fun. The problem with wheel throwing is you can show a bunch of pictures, you can show some YouTube videos, but unless you're willing to reenact Ghost, it's not really a thing that I would bring to PhreakNIC.
The hotel would probably not be happy about the clay puddles on the carpet.
Yeah, that's also a thing. That's actually something that you really want to pay attention to if you're going to get into pottery in general. Is clay is really, really bad for you to breathe. So you want to maintain a very clean work environment for the pottery stuff. Because ceramic is silicon based, if you wind up breathing clay dust, you get silicosis. And silicosis is, like the symptoms of silicosis are the same symptoms of tuberculosis. And it sucks. So, like, it will stay with you a lot longer too. It's not something you really get over. So keep, like, if you're gonna do this, then clean up spills, mop, it's like, pay attention to your work environment. So this is after it had already sat, and right before we pulled it out, and then we cleaned up the edges, and then we're doing some candling. There's a couple of different stages for once you have an actual clay body that you're, a thing that you want to turn into pottery. There's greenware, which means it hasn't been fired yet. There's a couple of different stages of wetness of that thing. So leather hard is the stage where you can work with it. You can take little knives and carve it pretty easily, and you can paint it with underglaze, and you can do some neat things with greenware before you fire it. Then there's bone dry. What we did, what I usually do is I'll wait for the clay to get bone dry, and then I'll come back with a wet sponge and clean off the seams at that point. So with two and multi-part molds, you definitely get to deal with seams. The way you deal with that is with a sponge at the pre-firing stage. After that, you can still, after it's been fired, you can go back with sandpaper, but now you have to deal with dust again. So it's just way easier to do stuff when it's wet than when it's dry, or when it's fired. So once it's greenware, another stage before you fire it is candling. Most cheaper kilns don't have a candling setting, and so basically when you put it in to the kiln, you turn it on, and it's on, like it's heating up, and your target temperature is I think like something on the order of 1200 Fahrenheit. I mean, it's super hot. Now what that means is that there is like even if it's bone dry, like it's so dry that you touch your tongue to it and it sticks, super dry, there's still water in this thing. So when you fire it, if you haven't candled it, the water in the walls of the ceramic will come out because it's going to get hotter than the boiling temperature of water before, like faster than the water can escape from the pottery itself. And so,
I can say from having had somebody else make a mistake in the same kiln where some of my stuff is fired.
Yep.
Try to fire it before it's all the way dried out, it will shatter.
Yep.
And it'll probably shatter pieces near it too.
yep, that's a thing. So, so in order to prevent that from happening, what we do is we stick it back in a regular oven and we set it to warm, or we set it to 200 degrees. You don't want it to be to go above 212, but you want it to be hot enough that you're wiggling the molecules of water out of the structure of the piece.
Is that the candler?
That's candling.
Okay.
So you like really fancy kilns where you're able to program it. You can set a candling stage where you say, all right, raise it to 200 degrees, leave it there for 3 hours, and then ramp up to the target temperature. With cheaper kilns, like if you buy a kiln on Craigslist, unless you get a crazy deal, you're going to buy a kiln that is controlled by a cone, and that is going to not have anything special like that. So the candling phase is very, very important, unless you just enjoy vacuuming up ceramic shards off the bottom of your kiln.
I was going to say, for people that aren't into candling, like I heard the term cone for years and never knew what it meant. I didn't understand that there was a physical cone. Was it at a temperature range?
Mm-hmm. Yes. So I actually have a picture of that here. Well, can't see the mouse. Right here, there's basically 3 things that are sticking out. So there's a bar that will drop down when the candle gets, or when the cone gets mushy, and when it drops down, it's on a pivot, and it'll release a latch once it on the other side of the pivot. When it drops down, the other side raises up, and there's a little trigger that basically is on a hook, and when that trigger raises, it'll come down and pop and break the circuit and cut off the kiln. So basically, there is a physical cone of material that has been calibrated to melt at target temperatures, and you basically buy these cones at various ratings. So when I say in this slide, firing to cone 07 versus firing to cone 8, that is what I'm talking about. The cone setting is the temperature of the kiln that is being raised for the various phases. So the first time you fire the pottery, you're doing the bisqueware fire. That's a lower temperature. Cone 07 is a lower temperature than cone 8, like by something like 15 steps. There's about 45 degrees between steps. No, I think it's like 15 degrees. Second? Okay, yeah, I've been checking. I'm actually really close to being done, so I'm right on schedule. Basically, the way it works is the cone scale starts at cone 022 and then counts down to cone 01, and then flips over to cone 1 and then counts up from there to, like if you're doing porcelain, then you're talking about firing to cone like 10 or 12 or something crazy like that. Our kiln only goes to cone 8, which is why I ever fired to that. Cone 8 is stoneware. It's nice, solid but yeah. If you're doing porcelain, you have to fire to a ridiculous temperature. So, you fire to the go, yeah.
When you said that inside of the kiln, it looked like there were a bunch of, were those slots for shelves?
Those are slots for the heating elements. So the heating elements actually nestle down in there. They heat up inside the wall of the kiln and then radiate heat inward. So yeah. So you do the bisque firing. What that does is that actually turns it into ceramic. It goes from mud to ceramic for the bisque firing, but it doesn't seal it up. When you fire to a stoneware temperature like cone 5, 6, 7, 8, something like that, that causes the structure to crystallize and lock in, and it becomes a lot denser. So you actually see more shrinkage for the glaze fire than you do for the bisque fire. And we've got some. This is actually a mixed bag of stuff. The bowl in the middle, I kind of did an experiment with it where I cast this or I cast it in this, and then just without doing the bisque firing, I dipped it into glaze, rekindled it, and then fired it. So that was actually firing last night. So.
Are you using several different types of slip there? I noticed some things are pink and some are green.
That's actually glaze. So this is a glaze firing. That's going to fire to cone 5, and so those will darken up considerably. They'll go from that kind of pink color, and you can kind of see this is a little bit of a blue green. The frog will go to hunter green. These guys will go to kind of a burgundy. And so, yeah. So, any questions in the 5 minutes I have remaining? Sure.
You did a great job.
Well, thank you.
And you look great.
I'd love to have a day with you at the shop doing this.
Say again?
I'd love to have a day with you at the shop doing this.
Absolutely.
If you could plan it for a weekend, I would come from Nashville.
Okay. Yeah, absolutely. Are you on our general mailing list? Okay. I usually announce stuff like that in like I'm not really great at planning for stuff, but yeah, I can announce stuff like that in the. We have a mailing list for the public, and we also have private or members only mailing lists. And yeah, if you hop on what is it, list@makerslocal.org or lists.makerslocal.org, you can sign up for the general list, and it's usually a bot announcing events, but occasionally it's people hopping on and saying, hey, I'm going to do welding this weekend, or hey, clean up your mess.
We don't have that. Yeah.
Nobody ever makes a mess. What's the connection to 3D printers?
So earlier in the thing, I was kind of talking about using 3D printers to make the positives. So this was 3D printed. This was 3D printed. We 3D print it, and then we make a plaster cast of the 3D print in order to do the mold.
One last question for you. Once you've used the plaster cast to make it, can you then dry it out and reuse it?
Absolutely, yeah. That's I've actually read articles on the internet. I've not done it myself because I'm actually just now getting into the use of slip that has a deflocculant, and so I've read articles where they said you shouldn't use your molds more than like 3 times a day. And I'm like, holy crap, 3 times a day. Like I'm doing good with the amateur slip. As much water as I put into it, I'm doing good with doing it like once every 3 days because there's so much water that it's got to deal with. But I mean, I can believe it having seen the thing ready to pull out of the mold in an hour or 2. So yeah, you can actually the plaster will reach saturation after a couple of uses, but then yes, absolutely, you can stick it in a dehydrator and then dry back out, and it's good to go the next day.
I was gonna ask if have you discovered like a level of detail where it's like you got your 3D printer and you made something that had a lot of detail in the 3D printer, but it just can't capture the play?
The limit there is going to be that you're dipping it in wax, not that the plaster can't take it. The plaster will. I've cast stuff where I was like, wow, I can actually see the ridges from the 3D printer because I was using a 0.3 millimeter layer height, and I just didn't have the wax that thick on that thing. So yeah, it can pick up all the detail, like all the detail.
For really complicated shapes, you can do what's called wax casting, where you have a wax pot that burn away.
We've done that for metal casting.
But yeah, I don't think it's easily done for ceramics.
No. What you do with metal casting is you take the plaster, you mix what do you call it, playground sand in it, and then you can use it. You can cast it the same way. You have to kind of candle. There's a step there where you have to kind of candle the plaster because you're pouring hot metal into this thing, and so you basically melt the wax out of the mold, and then you burn the wax out of the mold, and then you raise the mold to the melting temperature of the metal that you're pouring into it, because otherwise there's going to be like a crap ton of thermal shock, and so you have to get the actual mold up to 1100 degrees if you're doing what do you call it? Aluminum. What?
Speak to Queens.
Aluminium. All right. I'm gonna say I'm done.